Hi, everybody. This is Monica Paolini from Senza Fili, and this is a conversation on Terragraph and the opportunity that it opens in using a millimeter wave technology in many different environments. And today I have the pleasure to talk to Scott Imhoff, who is the Senior Vice President of Product Management and Planning at Cambium. Scott, thanks for being with us today.
Thank you, Monica, for having us. It's a pleasure to be here.
And to get started, can you tell us what is that you do at Cambium? You've been working on wireless technologies for quite some time, and you can give us some perspective on what you did, what you've been doing, and why is that you moved to Terragraph.
Sure. So you're right. Fixed wireless broadband has been in our DNA for quite some time. Cambium Networks came into being in October of 2011 as a divestiture from Motorola. And even within Motorola, we were a business unit focused on fixed wireless broadband. And in that context, historically, we were connecting people and places, more recently, people, places, and things. And we use a variety of different technologies to do that, proprietary, standards-based, licensed and unlicensed spectrum, and a variety of architectures from point to multi-point, now mesh, but Wi-Fi and LTE, to bring broadband and in some cases narrowband to facilities and resources that require it.
So how did you come across Terragraph?
So we came across Terragraph approximately 2 years ago, and it was an outcome of our investigation into the use of 802.11ad to support 60 gigahertz. So we started down a path of really implementing 60 gigahertz using AD, started down that path and concluded quite quickly that with the acceleration of AY, that AD would really come to end of useful life, primarily from an economic standpoint. And as part of that investigation, and due to some engagement with Facebook in Express Wi-Fi, became familiar with the Terragraph exercise and recognized the value that it was going to bring to 60 gigahertz and the impact that meshing would have on the usefulness of 60 gigahertz spectrum.
So was it the mesh or was it AY that was the major driver for you?
Well, first it was AY. We recognized the capabilities that AY were going to bring, TDD, a higher number of client nodes, just a variety of different considerations of AY. I would say Terragraph was icing on the cake and really expanded in our mind the usefulness of 60 gig, the use cases that it was applied to, and indirectly would impact the economics of a wide area network using 60 gigahertz.
So how does exactly Terragraph impact the economics of the 60 gigahertz band?
Well, it allows us to more efficiently deploy a wide area network that provides alternate path for data. So we can better enable the line of sight requirements. We can better accommodate atmospheric conditions that may interfere with performance. It eliminates the need for ingress points by moving traffic across the network. So it just gives you a lot of flexibility to design a network, to bring broadband to discrete addresses within that network more efficiently, and enables higher levels of reliability without necessarily requiring additional ingress points.
So it's the flexibility, the flexibility is a major cost benefit because it allows you to do things the way you need it. So you don't need to over-engineer a network.
Correct. Yeah, it allows you to efficiently engineer the network, I would say.
Yeah, absolutely. And what is the role of mesh specifically of mesh within Terragraph in that respect, in terms of performance and cost and business model support?
Well, from our standpoint, first of all, not all networks require mesh, right? Mm-hmm. So if it's a simple point-to-point network, small cell backhaul, perhaps it's a small point-to-multi-point network, single distribution node, we don't require nor do we expect all networks to utilize mesh. So it is a tool within the network arsenal, if you will, to meet specific requirements. And in terms of how do we use the mesh, it's really the intelligent routing of that traffic. Not to oversimplify it, but oftentimes people think of mesh as very complicated, particularly when mesh is manually networked or manually architected. But the fact that it's an intelligent mesh, we don't need to do that architecture, that it can discover and route traffic, simplifies the use of the mesh and demystifies it for deployment.
Yeah, but at the same time, it's still something on top. So if you don't need it, why use a mesh? You only need a point-to-point or a point-to-multipoint. So can you give us some examples of a place where a mesh is absolutely necessary and one where you really do not need it?
Sure. So our very first commercial sale of a CN Wave, our product that incorporates Terragraph, was actually to a chemical plant for campus area networking. And they're using it to provide gigabit transport for outdoor Wi-Fi and CCTV cameras. And in that case, it's a linear path network, and there's no meshing involved. We do think, and we're seeing this come true in some of our larger networks that are providing broadband access to residential and enterprise networks in urban environments, meshing is almost always going to be utilized, simply because of the wide geographic area that they're looking to deploy. And our early examples of customers are doing just that.
Yeah. So you see now moving forward, you see like an increasing use of mesh, but not necessarily everywhere. So you're going to see more of a hybrid network, or is going to be a network that is going to be one or the other?
Yeah, that's an interesting question. I suspect that there'll be more deployments without mesh than with mesh. And the reason why I say that is you'll see far more deployments of simple point-to-point, maybe single node, point-to-multipoint deployments. But the networks that utilize mesh will be significantly larger and consume far more devices. So hypothesis, ask me again in 3 years. I think you'll probably see more deployments of networks without mesh, but more nodes in the 60 gig space utilizing mesh, if that makes sense.
No. That's a very interesting point, because basically mesh is what allows you to scale to big networks, which Correct. Is what we want to have to get to the big market. And then the combination of them is actually good, because that widens the overall total market.
Sure. We expect individual customers to utilize mesh in parts of their network and not use it in other parts. We fully expect hybrid to be the typical model.
Mm-hmm. Now, let's talk again about, final question about mesh. Mesh is one of those things that, if you remember, like MIME or beamforming used to be like that too, that it's like captures people's imagination because the potential is huge. But on the other hand, for a long time, it was difficult because it was too complex. It was not working quite right. And it looks like with Terragraph, we got to a point where you can actually use the mesh, but it still adds complexity, as you were saying. So how can an operator, a service provider, manage that complexity? How can you help them do that?
Well, so from a personal experience, I was at Motorola when Motorola acquired a company called Mesh Networks in the early days of the infatuation with mesh. Came out of DARPA, and anything that comes out of DARPA, you can imagine, is complex. And it was really cool. It worked phenomenally well when it worked. And when it didn't, it was challenging to sort through why it wasn't working, both from an embedded software standpoint, but also more critically, the network design itself. And I think what has happened over the intervening years is just this iterative development on meshing technology, the algorithms, the architecture behind it. Our job and Terragraph's job via Facebook was to simplify that process, to simplify the architecture, to simplify the algorithms that were making the decisions, to embed the intelligence in the controller so that the network operator themselves, frankly, wouldn't have to deal with that, to disintermediate the complexity embedded in the controller and let the network operator receive the benefits of the mesh without having to pay the penalty of babysitting the mesh. And I think Terragraph has done a wonderful job with that.
Yeah, absolutely. Yeah, and that, I guess it's a crucial element of in the success moving forward. And I guess there's still, improvements to be made. One thing about Terragraph that might create some worries is, or actually, or maybe attraction, I don't know, is the fact that it's all based on a Facebook IP that it's open available to everybody. So is there room for vendors to differentiate?
I think there is, and we within Cambium are very focused on that value-added differentiation on top of the baseline that Facebook has brought forward, and Facebook is continuing to iterate, and I think you'll see improvements in the base product. But I also expect that companies like Cambium will provide value-added differentiation on top of it based on our own historic experiences and the customers that we're seeking to support and serve going forward. And the platform allows for that.
So what can you give us some examples of what is your secret sauce? What is that you provide that you think it's going to be very helpful to service provider?
Well, a little too early on specific feature functionality. We just put our first release into the market and began commercial shipments in December. And we've got a couple of software releases on scheduled through the course of 2021, and you'll see some of that differentiation start to come forward. But one of the I don't know that it's unique per se. Not all manufacturers have their first releases out yet, but we're supporting an onboard controller. So you can nominate one of the distribution nodes to act as that on-site controller for a finite number of nodes. So if you have a 2-site, 3-site mesh that you need to put together, and you don't need dedicated or focused computing horsepower to support that, nominate one of those distribution nodes to be the controller, and away you go. Then we offer for larger scaled networks that do require the computational horsepower. We can offer cloud hosted controller, or we can provide an on-prem controller if the customer prefers that. So we're looking at the mesh as an enabling tool, and we're providing flexibility on how network operators are going to implement and support that mesh.
So basically, you'd have two different models for the mesh. One that is more geared towards smaller networks that probably don't need a whole lot of the same set of functionality that big networks do, right?
Sure.
So that you can just get it across the different type of use cases.
Sure, I'll give you a practical and simple solution. I think 60 gig is inherently optimal for urban environments, dense networks, high data rates. But we also see strong interest in smaller communities in rural markets. So if you can imagine small town America, a single 2-lane road running through the middle of town, and they want to bring high capacity broadband to the storefronts and the restaurants and the courthouse, along that literally single road. They could put a 3-node, 4-node mesh down Main Street and be done. And it's a very simple mesh. All they're doing is looking to disintermediate multiple ingress points, maybe one at each end, but they need connectivity across the 3 or 4 distribution nodes. Simple mesh, done. And they can do that with an onboard controller. Maybe they take it down Elm Street, and Oak Street on the left, but not overly complex, not a huge geographic area, but it gives them a tool to simplify their network design and deployment.
Absolutely, and that's again, that goes back to the flexibility that we're having with Terragraph. And actually, so you brought up a different area that I would like to explore with you, which is the use cases.
Mhm.
And so, clearly you can be a provider for fixed connectivity to home and businesses, but which is a very good model. But is there more to Terragraph than that?
So right out of the gate, we have multiple use cases being deployed right now commercially. The obvious one is urban deployment for residential enterprise access, multiple deployments of that taking place right now. And those operators are providing broadband to homes, they're providing broadband to multi-dwelling units, they're providing broadband to enterprises. They've got some secondary revenue streams where they're providing transport for outdoor Wi-Fi access points and CCTV cameras on that same network. pretty straightforward. We have engagements with a mobile network operator who is deploying the V3000 as point-to-point to transport small cells. So a series of point-to-point links, effectively. A couple places they're using point-to-multipoint off of a distribution node, but predominantly point-to-point. So that's out the door. We have actually multiple cities that are deploying it as municipal networks. And they're using it in conjunction with other technologies. One on the West Coast is providing outdoor Wi-Fi access for their city employees around the city, and then also using it to provide secondary path for broadband to enterprise or to municipal facilities. So they're bringing broadband to the offices of the city. We have another city that's doing something similar, but they're providing outdoor Wi-Fi access for residents and visitors, but also providing CCTV transport as a city service for public safety. So we're, and I mentioned earlier, the chemical plant that's using it for campus area network. So we're seeing a lot of different use cases using the same product, fundamentally the same architecture, different use cases. And the common denominator on the use of mesh is geographic coverage. The larger that network becomes geographically, the more imperative the use of mesh is. Now, maybe the exception to that is when you need to go around a corner. The example that I gave earlier of the small town Main Street, linear path of 4 distribution nodes. But the common element is the geographic coverage necessitates the use of mesh for an efficient network design and build out.
And also that allows to use it for different applications in the same location. So you could have a city that has multiple applications. Well, clearly they would not just have one. Typically, you just have multiple applications. And but you mentioned public safety, and public safety, unlicensed band. Is that an issue there?
It is if you don't architect or engineer the network. Our feedback to our partners and our end customers is, if you're familiar with 5 gigahertz point-to-point, point-to-multipoint, it's a relatively forgiving band in the sense that you don't have to have it optimally aligned for coverage. You got a wide angle antenna. It'll, as long as you're line of sight, it'll generally take care of you. You go to CBRS 3 gig, you get a little near and non-line of sight. You get a little protection from the SAS in terms of interference. They're forgiving. 60 gig is absolutely a line of sight. No such thing as non-line of sight. You have to be certain on your RAIN region. You need to engineer that network to have alternate paths if it's public safety. So our belief is, if you use the tools, the network planning tools, C and Heat, Advanced Network Planner, Link Planner, and you engineer the network to provide 4 nines or 5 nines of reliability, you will get 4 nines or 5 nines of reliability. But you have to engineer it up front to deliver to your expectations. If you don't do that, then no, you're not going to be satisfied with the end result.
Yeah, absolutely. So you need to know what you're doing, and probably, as with everything, you probably need to have different access, different transport technologies. It's not necessarily just one that addresses all the public safety. Now, actually, talking about different technologies, there is some work being done to have 5G NRU to work in 60 gigahertz.
Mm-hmm.
Do you think that that's going to work out? I mean, do we need another technology in the same band?
So we're certainly aware of it, and we're tracking the evolution of 3GPP's efforts there. We Cambium have a 3GPP 5G fixed development underway using 28 gig actually, and it'll be deployed in the second half of 21 commercially. So we're tracking to it. We're familiar with it. We consider ourselves technology agnostic. I mentioned on the front end, we have proprietary technologies, we have standards-based technologies, we have a 4G network in our CN Ranger platform, we use licensed and unlicensed spectrum. So our view is it's a horses for courses discussion. If you're a horse racing fan, hopefully some of your viewers are, you've got horses that can run on turf that can't run in the mud. You've got horses that can run in the mud but can't run on sand. It's the right horse for the race. And at the moment, frankly, 802.11ay with Terragraph is the only horse in the race. So we're right now addressing all use cases and applications with that technology suite. It's unclear to me at this point what problems we can't solve with that we would solve with a 3GPP solution, but it may come to be that those use cases emerge and there's applications for that particular technology suite. And if it makes sense to develop against it, Cambium will.
Yeah, yeah. Well, I guess it could be more like for like an indoor type of coverage, in which case it's just pure coexistence. It's not even competition.
Sure. I guess somewhat similar to the 28 gig that's taking place, where there's an indoor play for it, there's a mobile play for it, and there's a fixed play for it. Our view is fixed is the most logical application of the technology, but that may come to be. Go back on the history of 60 gig. It was originally principally a military band, used quite extensively there. The FCC, one of the early adopters, saw opportunity for indoor networking using 60 gig, and that's kind of the backdrop to AD. Never really came to fruition by any of the big consumer brands, and was, I'd say, fallow for a period of time. And as commercial chipsets came available, courtesy of Qualcomm and others, and the AY standard emerged, it really aligned to the applications that we're seeing today, particularly for outdoor deployment.
Now, let me ask you a final question. This is Terragraph, commercial availability of Terragraph, it's very new. So I'm sure there is a lot of potential for developing the products and the solution in general in new directions. And so what is that you're working on? What's going to come next?
So I think we're fortunate from an industry standpoint that there's been a lot of groundwork done on optimizing AY, Terragraph, the early alpha and betas that Facebook undertook, and then followed by the investment that Cambium and other manufacturers have made in alpha and beta testing and working through the technology challenges. And I think what Cambium is coming forward with is certainly first generation, release one. But there's a lot of history already behind that technology, both hardware and software, and we're confident about the early deployments from a commercial standpoint. I mentioned earlier, we do have a robust software roadmap. So we've got sequential software releases scheduled through 21 and touching into the first half of 22 that will add additional functionality, features and services to it. We have three primary hardware elements in market today. Our V5000 distribution node, 280 degrees of coverage in a consolidated package, very compact. We have the V1000, which is the high volume client node. That's what you would typically see on a subscriber house or a CCTV camera. And then we have the V3000, which is a high performance client node, ideally situated for point-to-point types of applications, highest gain that we've seen any manufacturer release in the industry right now. We will be announcing a iteration of the V3000 that provides a lower gain reflector dish. So it shrinks the geographic size of the V3000, just reduces the gain a bit. So it kind of fits between the V3000 today and the V1000. You'll see Cambium bring forward new distribution nodes that provide performance and coverage deviation off of the V5000. And you'll see us bring forward additional client nodes to meet specific use cases and market requirements. So we're by no means done on the development side. We're firmly committed to 60 gig. And I think we're seeing a very strong market reaction to 60 gig as a band, 802.11ay as a standard, and the use of Terragraph across that network.
Yeah, and it would be good, it's like a high time to find a good use for the 60 gigahertz band, like so much spectrum.
It is. It is, and on one hand you've got short propagation, but on the other hand that allows for tremendous reuse of that spectrum. And you got very wide bands. You can legitimately deliver multiple gigabits of capacity, and you can do it in a very economic fashion compared to traditional buried fiber. I think you're going to see the first true competitor to fiber ever in the use of 60 gig.
Yeah. Yeah. What used to be the challenge is the strength right now, right? So it's all flipped. Well, Scott, thanks so much for sharing your thoughts with us today.
Absolutely. Pleased to be here. Thank you.
And thank you for watching. And this is part of a report on Terragraph, and that you can read and download from www.senzafili.com. And you can also read this interview in a transcript form. So thank you all for watching.